syntax is just fine. Let's try that again. I was expecting an error message, but I wasn't expecting that error message. Okay. Show me. No, that number's fine. Okay, let me delete. Okay, so that's 24. But if I put a 7 in there, okay. You know what's happening here? I don't agree with what's going on here, but once again, we're breaking the calculator. Your calculator, that's the problem. That's why it's saying syntax. Your calculator doesn't do times 10 to the 247th power. The largest your calculator does is times 10 to the 99th power. So it's saying I can't even plug that in. Which means, once again, I'm smarter than the calculator. I know this is going to be 247, even if the calculator doesn't. And you're smarter than the calculator too, now, right? Because if I change this to 347, the calculator still isn't going to know what that answer is, but do you? What's it going to be? 347, congratulations. I should give you like a certificate or something, right? You outsmarted the calculator. Okay, but it still says no, screw you. All right, so that's the first one. I don't think we need to spend any more time. I can now ask you to take the common log of any number, right? That the number the calculator can do. Let's quit. Oh, I know you guys didn't disbelieve me, but what happens if I try to take the log of 0? It says no, it's not in your domain. You can't take the log of 0, right? Or if you try to take the log of -1, can you take the log of a negative number? And your calculator won't let you. Your calculator won't let you be stupid, right? It's a non-real answer, which is different than domain, but don't worry about that. Okay? All right, so let's talk about the other significant log. Other significant log we call the natural log. Okay? If our common log was log base 10, the natural log is the y as a function of x that is log base e. Remember that e we were talking about? I didn't tell you had to memorize that number, but it was that number in between 2 and 3, that 2.7, 1828, 1828, blah, 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 that number. We used it for continuously compounded growth and such, okay? I'm just vomiting words, aren't I? I have no idea what I'm talking about. Okay, so when you have log base e, we give it special notation, okay? We call this ln of x. If you see the ln of x, that's understood to be log base e. Just like log with no base is understood log base n, when you see ln, we're calling that log base e. Okay? On your calculator, guess which button it is?
The ln.
Yeah, the ln button. Now, why does that seem appropriate? Do you remember how you get to like e? You hit second what? What's right above your ln button? E to a power, right? And it's appropriate that they've had them together because they're the inverses. They go together. They cancel each other out. Okay? I do want to say this. Has anyone up to this point heard me say IN? Is this an IN? If you put IN on your test, do you realize that's going to be ridiculous? Right? Especially since it's the LN button right there. Okay? I'm saying this because the first time I taught this, I was not expecting this. And when students took their test, like a third of them would write IN. It's like, where did the hell did they get IN from? But, I mean, I see now that my lowercase L looks kind of like a capital I. So for a while I was doing this. I don't want to write the cursive out. I just want to write my freaking L like I always do. Don't make me write cursive, okay? So, I will say this. If you put IN on your test, I'm going to make fun of you to my friends, okay? I probably won't take off points because maybe you're joking, but I will say, can you believe what they did? I did like a 10-minute spiel on how it's not IN, and they still put IN. Fair? Then you can put IN if you want, as long as you don't mind being ridiculed by me. You probably don't. All right. So we've got this natural log function. Now the natural log function, it plays similar, but just a little bit differently. So if I ask you, what's the natural log of 4? Then that's simple enough with the help of the calculator. Natural log of 4, close parentheses. And let's go to 4 decimal places. All right, so the natural log of 4 is about 1.38, what? 63? That's what your calculator says too, isn't it? Not just mine? Okay, what does this mean? If this is my base E, if my natural log of base E, if I take E raised to that number, what should I get? I should get 4. That's what this means. So if I try that, if I do second ln to get my E to the whatever, do y'all want to do that exact number or do y'all want to round it? Let's do that exact number. Does anyone know how I can get that exact number? There's a couple ways. Huh? I could have stored it, but it's too late for that. That would have been one way. Did y'all know about second answer? If you hit second, then your negative sign. Y'all see that ANS? That means use whatever this guy is. So if I do E to that number, I get 4. Now, what if I would have rounded it? What if I did E to like the 1.3863? Oh wait, yeah. Thank you. 1 point. I don't get 4 exactly, but isn't that pretty much 4? That's close enough for 4 for everybody, isn't it? Close enough to 4, or yeah. Okay. Now, why 4 decimal places then? What if I just rounded to the nearest whole number? If I just did E to the first power, that's not going to be anything close to 4, right? And nobody, I don't think, would have said, hey, let's round that to the nearest whole number. Is that true? So what if I did 2 decimal, like 2 digits, 1.4? If I did E to the 1.4, it's a lot closer to 4-ish, right? But I think we can do a better approximation. So if we did 1.39, just changing it by 100th, the approximation is a lot better, right? And if we did even better, if we did 386, that's really good. But if we add that last digit of significance, it's really, really good. It's even better. Okay? So on these guys, we're going to round most of the time, but we're going to round to 4 decimal places just for accuracy's sake. Okay?